Welcome back. This is the second video showing you some basic analyses with the syntax meaning. And we're in the same data set. So I'm in the positive affect data set. And I'm looking at these different variables here. So I have gender and age and Hispanic as my demographic variables, and then positive total, negative total, and satisfaction with life. So we're now going to do some bivariate statistics. The previous video included univariate statistics, which is a variable analysis of a single variable. So we looked individually at gender, we looked individually at age, we were looking at just that variable. So now we're going to look at some bivariate statistics. So the first that we're going to look at, we are going to do a Pearson's R. And Pearson's R is an effect size. So we're looking at the magnitude of the relationship, the size of the relationship. It's also a null hypothesis test, but for right now, we're going to use it descriptively. So by descriptive, I just mean that we're describing our sample and we're not making any inferences about our population. So when we go to analyze, you can go to correlate, bivariate. And you need to know what are appropriate measures for that, for this analysis. So for a bivariate correlation with Pearson's R, you need to have two variables. So bivariate is two. You need to have two variables that are continuous, that are in the scale level of measurement. And so here we have some different ones we can look at. We could look at age and the correlation between age and satisfaction with life. So I can go ahead and say, you know what, I want to do age and I want to do satisfaction with life. I'm going to move them over into my variables. And you can see here we're doing a Pearson's R. We'll talk about these other R's later, or these other coefficients later. We're going to do a two-tailed test of significance. We're not really going to worry about significance for this one, so I'm actually not going to flag significant correlations. And then I only want to show the lower triangle, and I'm going to show you why that is. So you can see that there's other options here. You can change the statistics that you're looking at. So I could add means and standard deviations, for example. I'll go ahead and do that. You can look at the style and you can add formatting. I'm not going to worry about that. And then we're not going to worry about bootstrapping and confidence intervals at this point. So now I'm going to say, okay, and I have the same output that I had in the previous video. So we're now looking down here. So first, here is our syntax. And we can copy that out and take a look at it. So again, SPSS is not creative with its names, which is great, right? We're going to do a correlation. The command is correlations. So we need to identify our variables. So you'll notice there's a backslash and then variables, and our variables equal age and satisfaction with life. We can do more than two. It's still just going to give us bivariate relationships between multiple variables. We're going to, this is saying print, it's saying that we're going to show two-tailed significance and that we're only going to do the lower triangle. And I specifically chose that, and I'm going to show you what that means here. So you can see here, this is the two-tailed. So here, two-tailed significance. That's this right here, two-tailed significance. And we're not going to worry about that because we're just doing a descriptive analysis right now, but that's what that means. And then by lower triangle, we're talking about just showing the responses here. If we didn't do that, we would actually just get the mirror image of this and it would be the same information. So it just adds noise to our table. So this is our correlations. This is our correlations table. And we are looking at kind of a small matrix. So we could look at a correlations matrix with lots of variables, which we'll do in just a minute here. So the other part that's here, I asked for it to add descriptives. So I said I wanted to have some descriptive statistics, and you can actually see here that age, it gave me the mean and standard deviation, and the sample size, and then same thing for the satisfaction with life. So it's a little extra information. You don't have to include that. So this syntax is really flexible depending on what information you want the output to have. I also included this missing pairwise because I wanted to exclude missing variables so that if we, it only shows a full pair, which we don't have any missing variables in this data set, but it's good to include that. So that is the syntax to get our bivariate relationship here. Now let's take this and let's modify it. So I'm going to copy this and leave my original. I'm going to say, you know what? I'm going to add my other variables that I can do this with. So I can't use Hispanic or gender because they're categorical, but I could add positive total in there. So make sure you spell it correctly. So I'm just going to put a space and I'm going to say pos total. And look at that. It's going to give it to me. I'm just going to click right there. I'm going to say neg total. And I can rerun this. I just added more variable names. And look at that. We now have a more complicated correlation matrix. And what we can see is that here, age, how old are you, age, is in this row right here. And that would be perfectly correlated because it's actually the same variable. So you don't have to worry about that one. But we want to know, how is age correlated with satisfaction with life? So that's this first one here. We can see that our Pearson correlation is negative 0.26. So I'm going to round up to 2 decimals. Again, we're going to ignore significance for right now, but we can see how many people, how many paired responses that is. That's 9. And we can go through and we can look at all of these different relationships. So there's a negative relationship of 0.26 here between age and satisfaction with life. There's a negative relationship between age and positive affect, and that number is negative 0.46. And then there is a positive relationship between age and negative affect, and we can see the Pearson's R is 0.46. So all of these tell us what the size of the relationship is between sets of 2 variables. So that's that bivariate. So this correlation matrix allows us to look at multiple bivariate relationships. So this is a bivariate descriptive analysis. And again, we could look at significance, but we're going to save that for when we talk about that later on. So that is how you conduct a correlation test for bivariate statistics for descriptive. And you can see again that we have our syntax here, and we can modify it as needed.